Question 1.1.1. Solve for x squared plus 9x plus 14 equals 0. Well, this is a gift for 3 marks. It's factorizing a quadratic. Now the rule on factorizing a quadratic is FOIL, first, last, inside, outside. In the first term, the coefficient for x squared is 1, therefore the first term of each factor must be 1 as the coefficient in both terms. For the last term we need factors of 14. This can be 1 and 14 or 2 and 7, and I can already see that this is 2 and 7. Because 14 is positive, either both factors are negative or both factors are positive. Now the inside and outside must add up to plus 9. That is plus 7 plus 2. Therefore the factors are x plus 2 and x plus 7, or x equals minus 7 and x equals minus 2. More factorizing quadratics. The giveaway here in this question for 4 marks is the term corrected 2 decimal places. And this means we're likely to have to use the formula from our info sheet. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. Now to take this formula and plug in the coefficients, and we get this rather complex formula. Simplify, doing the arithmetic. Now you can use your calculator to calculate that x equals 0.29 or x equals minus 2.54. There's another way to do this by completing the square. I'm going to revise that for you. To solve the equation x squared plus bx plus c equals 0, consider the expression x plus b over 2 squared plus c. Now this expands to x squared plus bx plus b over 2 squared plus c, which is the same as the original equation plus b over 2 squared. So to get back to the original equation, we subtract this a term from, and we get x plus b over 2 squared minus b over 2 squared plus c equals 0. This can be rearranged to be x plus b over 2 squared equals b over 2 squared minus c. Take the root of both sides and solve for x, and you'll get it. Right, so let's take a look at our equation. First, divide our equation by 4, so that we get a equals 1, b equals 9 over 4, and c equals 3 over 4. Then add the term 9 over 4 over 2, or 9 over 8 squared, or 81 over 64 to both sides. Then you get x plus 9 over 8 squared equals 129 over 64. Just take a little moment to check that you get this arithmetic. Then x plus 9 over 8 is equal to plus or minus the square root of 129 over 64. Put this into your calculator and you get x equals 0.29 or x equals minus 2.54. Question 1.1.3. Now look at this question, and the first thing you're going to see is we've got to get rid of these surds. Right, so square both sides and we're left with x squared minus 5 equals 4x. Bring the 4x over to the left hand side and we have a quadratic in standard form. X squared minus 4x minus 5 equals 0. This is going to be easy. Apply FOIL. First, the x times x components will each have a 1. And the last, only the factors of 5 and 1 make up 5. So this is going to be x something 5, x something 1. Get the minuses and the pluses right. You need to get to minus 4. So it'll be minus 5 plus 1, x minus 5, x plus 1, or x equals 5, or x equals minus 1. Put those back into the original solution and you'll see that only x equals 5 is a real solution. Question 1.2. This is for 6 marks, but it's actually just a simple substitution. You just have to focus on getting the algebra right. Take the first equation and get it in terms of y. So y equals 3x minus 4. Now substitute this into the second equation, x squared plus 2xy minus y squared equals minus 2. And this gives us x squared plus 2x into 3x minus 4 minus 3x minus 4 all squared equals minus 2. Multiply that out. X squared plus 6x squared minus 8x minus the quadratic 9x squared minus 24x plus 16 equals minus 2. This quadratic is related to 3x minus 4 squared. Now gather the right terms. 7x squared minus 8x minus 9x squared plus 24x minus 16 equals minus 2, or minus 2x squared plus 16x equals minus 14 equals 0. Divide everything by minus 2 and you get x squared minus 8x plus 7 equals 0. And that's really simple because with applying FOIL it's 1 and 1 for the x's. 7 can only be 7 and 1, but you need the same signs because it's a plus. So 2 minuses will give you minus 8. Minus 7x minus 1x gives you 8x. So it's x minus 7, x minus 1 equals 0. That means x equals 1 or x equals 7. Now you can apply this back into the first equation, and y is equal to 3 times x, or 3 times 1 minus 4 is minus 1, or y equals 3 times 7 minus 4, y equals 17. Question 1.3.1. For 3 marks, given that f of x is equal to x squared plus 8x plus 16, solve for x if f of x is greater than 0. There's a few ways of solving this, but I'm going to start with a quadratic. X squared plus 8x plus 16 is greater than 0. Solve for that equation. We'll factorize this into x plus 4 times x plus 4 is greater than 0. Now let's look at the cases here. At x equals minus 4, f of x is equal to 0. If x is greater than 4, so that's a number is great, is a positive, and x is greater than 4, that number is positive, then the two positive terms multiplied are always greater than 0. Similarly, where x is less than 4, the two positive terms multiplied, they're both negatives, are always greater than 0. So then x is an element of minus infinity to minus 4, or when x is an element of minus 4 to infinity, anywhere on the real number except equal to 4. We can write this as x less than minus 4 or x greater than minus 4. Let's look at it with a graph. So the quadratic is x squared plus 8x plus 16 is greater than 0, and the factors are x plus 4 greater than 0. So where x equals minus 4, f of x is equal to 0. Now if we're going to draw a parabola, that parabola is going to be smiley face up because a is greater than 0. And therefore the graph must go upwards from minus 4. This means that x is an element of the real, but it's not equal to minus 4. It's at minus 4 that the graph just touches, and therefore x cannot be equal to minus 4 and still be f of x greater than 0. Question 1.3.2. For which values of p will f of x equal to p have two unequal negative roots? Okay, there's a few ways to do this. Starting with the graph. If p is less than or equal to 0, then f of x is greater than 0. So for all roots, p is greater than 0. If when p equals 0, we have f of 0 equals 16, that means the y-intercept is at 16. And we can keep pulling the parabola down until p equals 16. So therefore we have unequal roots when 0 less than p less than 16. Let's just do this algebraically. X squared plus 8x plus 16 equals p. X squared plus 8x plus 16 minus p equals 0. Therefore, 0 less than 16 minus p less than 16. And minus 16 less than p less than 0. So 0 is less than p less than 16. Let's just look at that again. We could use our quadratic formula. Minus b plus minus the square root of b squared minus 4ac. And then for the roots to be real, we must have 0 less than b squared minus 4ac. And for them to be negative, we must have minus b or minus 8 less than b squared minus 4ac, or less than 8 squared or less than 64. That's b equals 8 and c equals 16 minus p. Therefore 0 less than 4p less than 64, or 0 less than p less than 16. Now here's the most elegant of all of them. Go back to the quadratic. X squared plus 8x plus 16 equals p. X squared plus 8x plus 16 minus p equals 0. Now for both roots to be real and unequal, that part from the formula b squared minus 4ac, or 8 squared minus 16 minus b, must be greater than 0. This is for real unequal roots. Therefore 4p is greater than 0, therefore p is greater than 0. The roots then are minus b, or minus 8, plus minus the square root of 4p. For both roots to be negative, we need the square root of 4p to be less than 8, or p less than 16. So 0 less than p less than 16.